when two or more signals or waveforms of the same frequency are added together, the phase difference between those signals has an effect on the sum that is produced. Depending on the sum signal, depending on the phase difference, the sum signal may exhibit amplification, which is an increase in its amplitude relative to the original signals, or it may also be attenuated. And attenuation is nothing but the amplitude of the sum signal being reduced or being made smaller as compared to the original amplitude of the signals that were added together. And whether it is amplified or attenuated, that depends on the phase difference between the signals that are added together. For example, if we see the red waveform in this figure here, it is a sine wave of a particular frequency, and the blue waveform is also a sine wave of the same frequency, but it has a phase shift of theta. And for illustrating this, I'm going to vary the phase angle theta. So the phase angle theta is going to be varied between minus 2 pi and plus 2 pi, and we will see the result of this on the sum waveform, which is denoted by the black waveform y, which is y1 plus y2. So the red waveform is going to be the reference waveform, and the blue waveform is also a sine wave similar to the red waveform, but it is going to have some phase shift theta, which shall be varied between minus 2 pi and plus 2 pi. And what we will see is, when the two added waveforms, or when the two added signals have zero phase difference between them, as in this case, so the phase difference between the two is zero, that means they are perfectly aligned with each other, in which case the sum waveform has an amplitude which is maximum. And as we start to shift the phase of the blue waveform, we see that the amplitude of the sum becomes smaller and smaller, and at one point it becomes smaller than the original waveforms. And if you notice, at this point the sum waveform is completely cancelled out. So the amplification is maximum when the two waveforms are perfectly aligned with each other, or we say that the two waveforms are in phase. So we say that the amplification is maximum. Amplification is maximum when the two waveforms, or when all the waveforms are in phase with each other. See that chart? That is, they are in phase means the angle between them, theta, is equal to 0, or theta is some multiple of 2 pi. So it is n times 2 pi, where n is any integer. Now when the two waves are out of phase with each other, as it is now in this image, so it is completely out of phase now. So when it is out of phase, it means the phase difference between the waveforms is 180 degrees or pi. So that is when the attenuation is maximum. So the waveform attenuation is maximum when the waveforms are out of phase. Out of phase, that is theta is equal to 180 degrees, or it can be plus 180 or also minus 180. So we can say plus or minus 180 degrees. So let me write that clearly. Theta is plus or minus 180 degrees, or we can write that as plus or minus pi. So that's when the two waveforms, all the waveforms will cancel out each other, resulting in the amplitude of the sum waveform being completely zero as we see in this plot. So let's play out this video so you can see the effect of phase shift between the red and blue waveforms. So when the red and blue waveforms are perfectly aligned with each other, that is, they are in phase, the amplitude of the sum waveform, the black waveform, is maximum. And when that alignment gets shifted, that means when as theta is varied, the amplitude reduces, it gets attenuated, and when it is 180 degrees or pi radians, the sum waveform completely cancels out. That means its amplitude becomes zero completely. It's like a DC signal. So we notice that the phase difference between the waveforms has an effect on the sum signal. So we call this effect as wave interference, how the two waves are interfering with each other. The interference is said to be constructive when the waveforms are in phase, or at least the phase difference is such that there is some sort of amplification in the resultant signal. But if the phase difference is such that the resultant signal's amplitude gets smaller than the original signal's amplitude, then we say that the interference is destructive interference, and that is the case when we have attenuation. So we'll see those two specific cases separately. So we have here constructive interference, where the red and blue waveforms are perfectly aligned together. So the black waveform has a maximum amplitude in this case. So there is constructive interference, which results in amplification of the resultant sum. So constructive interference okay, when does this occur? It occurs when the phase difference between the waveforms is the theta is equal to 0 or some integer multiple of 2 pi. So we'll write that as 2n pi, where n is any integer. And constructive interference will result in amplification. Amplification of the sum signal. This amplification is maximum when the phase difference theta is 0 or any integer multiple of 2n pi. Conversely, when the added waveforms are out of phase with each other, that is when destructive interference takes place. So as we see here, this is a case of destructive interference, where the blue waveform and the red waveform are completely out of phase, in the sense that when the blue waveform is having a positive cycle, the red is going through its negative cycle. and here when the red is in the positive cycle, the blue is in the negative cycle. So that means the phase difference between them is 180 degrees, in which case there is destructive interference. And when there is destructive interference, the amplitude gets reduced. The amplitude of the sum signal gets reduced. And when it is 180 degrees, when the phase difference is 180 degrees, the amplitude becomes completely zero. That means the two waveforms have cancelled out each other, resulting in zero level of the sum signal. So destructive interference causes attenuation. So destructive interference causes attenuation, and this attenuation is maximum when the phase difference theta is equal to plus or minus pi, or for that matter any integer multiple of pi, where n is some integer, in which case the waveforms just cancel out each other. So when theta is any integer multiple of pi, then the waveforms cancel out each other, Okay. This phenomena, it can be a problem in certain forms of communication systems where we get multiple copies of the same signal, and when these add up together, they may either amplify or they may attenuate the resultant signal, which can cause a fluctuation in the in the received signal. We'll discuss that in more detail in another lecture, but the focus here is just to understand the meaning of the wave interference and the effect the phase difference between signals has on the resultant sum, and when do we get constructive interference and destructive interference, and what is the meaning of amplification and attenuation in this context. So we will see that in this case the two waveforms, the sine wave represented by the red waveform and the blue waveform, have a certain phase difference between them, but the phase difference is not 180 degrees. And what we see here is that when adding these two waveforms, the resultant waveform, which is the black waveform, has an amplitude which is much smaller than the amplitude of the red or the blue waveform. So that means the sum waveform has been attenuated. That means the phase difference between the red and blue waveforms is such that it is causing attenuation of the resultant signal. So we have attenuation in this case. So attenuation, which is weakening the amplitude of the signal. Weakening the amplitude of the sum signal. Right? So to summarize, what we have discussed in this video is the effect of phase difference on the sum of two waveforms that have the same frequency, and when the two waveforms, or it can also be more than two waveforms, and when the waveforms are in phase, that means the phase difference between them is either zero or in such a way that they do not cancel out each other, then the resultant waveform will exhibit amplification, as we have seen here. So there is some amplification in the signal, and when the waveform is having a phase difference which is 180 degrees, it will completely cancel out for some other values of the phase difference theta. The amplitude of the resultant signal may be smaller than the amplitude of the original signals, in which case we call it as attenuation. And for theta equal to pi or 180 degrees, the attenuation will be such that the two waveforms simply cancel out each other. So when there is amplification, we call it as constructive interference, and when there is attenuation, we call it as destructive interference between the waves. Thank you.